This time, we are to evaluate the integral of z squared e to the power of z dz from 0 to 1. This is a complex integral, so we're talking here about a certain path, or c, from 0 to 1. So you have here the integral of that's z squared e to the z dz 0 to 1. You would notice here that you cannot actually just integrate this, treating one term as of course you have here the exponentiation, so you might be thinking e to the u du. If you're going to pick e to the power of z as your e to the u, du would just be dz. But you have z squared here. In short, obviously, this would need the idea or the process of integrating using by parts. Okay, yes, by parts. You have here a z squared, which is algebraic in nature, and e to the power of z, which is exponential form. We know that for the integral, okay, let me have it read, of u dv, where of course we cannot integrate them just by automatic integration, this is equivalent to uv minus the integral of v du. So we need to identify the du and v as we identify these two. And how do we identify the u? Take note, we are using here this mnemonic. We consider the logarithmic forms first, then we have the inverse forms or inverse functions, the algebraic functions, the trigonometric functions before the exponential form. That would mean z squared would be our u. Okay, so our du is 2z dz. Take note of that. That would also mean that our our expression dv, since we picked z squared as our u, so this entire form is our dv. Okay, so this means, sorry for that, our dv, let me use red, is what do you call this one, e to the z dz. Okay, as we take the integral of that, so that v will appear, the integral of e to z dz is just e to the z itself. Okay, so as we continue that's our integration by parts. So again, this would be your u and this is your dv. This is equivalent to uv minus the integral of v du. Okay, so our u identified earlier is z squared. So this is z squared, and your v is e to the z. E to the z. Okay? But you are to evaluate that from 0 to 1. Right? So let us try to evaluate that 0 to 1 minus the integral here, still 0 to 1 of your v, which is e to the z, and your du in this case, 2z dz. Okay? So 2z dz. Now, before we simplify this, take note, we still have the integral here, and let's examine that further. You would still notice that there exists a z here. As mentioned, if we're going to treat this e to the u, the du must be a certain function notation itself, but this has z here. That would mean we will do here a double integration by parts. Yes, we are going to integrate by parts twice. So let me have it here. Allow me again, according to this mnemonic, this would be my u sub 2, and this would be my dv sub 2. Okay, so pardon with all of those notations. So if my u sub 2 is actually 2z, my du sub 2 is 2dz. Okay? Now, for my dv sub 2 is e to the z dz, by integrating that, dv sub 2 e to the z dz, v sub 2 is e to the z itself. That would mean for this second item, we also have another form in this manner. So this means you still have here, take note, okay, that's minus, so everything else will be applied later. Let's talk about that later. So this is u v sub 2, so I mean u2, so 2z, okay, 2z, and then v, e to the z, still 0 to 1, minus the integral of your v sub 2, e to the z, and this time our du is just 2dz. But this 2 can be moved out. So this is 2z e to the z, okay? So from 0 to 1 minus 2, this is 0 to 1, right? 0 to 1 e to the z dz. Take note, again, let me write this here. These are all under minus here. Don't forget that grouping symbol. Very important. Z squared e to the z, still 0 to 1. Right? So as we continue, let's simply finish this, and that's already good to be integrated. This is z squared e to the z. Hopefully the space are enough at the bottom. Yes. 0 to 1. You have minus, again, the grouping symbol here. 2z e to the z from 0 to 1 minus 2 e to the z 0 to 1, as the integral of that is e to the z. Okay, now before we apply the limits of 0 to 1, let's break these grouping symbols. Z squared e to the z from 0 to 1 minus 2z e to the z 0 to 1, and because of the grouping symbol, plus negative times negative, plus 2 e to the z is 0 to 1. Okay, that's the reason why we had the grouping symbol. Now, let's apply the limits, or the items, or to evaluate from 0 to 1. So you have here 1 squared e to the 1 minus 0 squared e to the 0. That's the first. Since the second term is preceded by minus sign, let's do not forget to use grouping symbol. 2 times 1 e to the 1 minus 2 times 0 e to the 0. We're doing this grouping symbol even if this is very clear not to be included later on in the final form. We're doing that to be consistent with all the processes. Finally, this is plus, no need for grouping symbol. 2 e to the 1 minus 2 e to the 0. Alright. So this is 0. This is also 0. This is not 0, that's just equal to 1, right? So that means, as we continue here, e to the 1 itself minus 2 e to the 1 and plus 2 e to the 1 minus 2. Okay? This is e to the 1 minus 2 e to the 1 plus 2 e to the 1 minus 2. Meaning the final answer here is e minus 2. This is the result for this given item after we have done 2 sets of integration by parts. And yes, that is also applicable for the integral of complex numbers. So this is the result, e minus 2, for this given item. Thank you very much for watching.